So now we're going to talk a little bit about XML schema. XML schema is a language that allows you to decide on whether or not a particular XML document meets a contract, an arrangement. So you have two pieces of software exchanging data using XML. And what if one of them, if they're all working, nobody really worries too much about it. But if all of a sudden one breaks, you change one side and the other one breaks, whose fault was it, right? Was it the side that got changed or the other side? And so you could argue. So what you like to do is before you set up these arrangements between these applications, set up a contract. In a way, they're kind of like the RFCs are, except that their scope is between pairs of applications. And so it itself is XML. And it basically, what we do is we take an XML document and an XML schema contract, and then we either say that's good or that is bad. And that's called validation. A piece of software that validates XML when given a schema is called a validator. And so an XML document, here we have our little XML document, we're passing it to the validator, and then we have a schema contract, which is itself XML. It's kind of a particular kind of XML, that XS: complex type. That's just a tag. Colon is a legitimate character for the name of a tag. Name equals person, that's just an attribute. And so XML schema is a particular format of XML that renders an opinion about what XML is supposed to look like. So there's a number of different XML schema languages. The one we're going to look at is one that's kind of came a little bit later, that's very common, called XSD, which is the World Wide Web Consortium's schema specification. Often you'll find files that have suffixes of .xsd that actually contain the XML, just like we're going to show you. So if you recall, there are simple elements which have text children, and then there are complex elements where other nodes are children of other nodes. And so we can say this. And so here we have a little bit of XML, and the XML schema that makes sense with that. So what we're saying is the outer tag of this legitimate XML is supposed to be a complex tag with a name of person. And so there we go. That looks good. Good, good. Then there is a sequence, and then there is a simple element, a name of last name, looks good. And it's a string, that looks good. Another tag that's of a named age that's of type integer, that's good. And then a thing that's called date born, and then there it looks like a date. So we check all these things, and we can basically say, yup, that is a good XML document according to this schema. And you don't have to write this generally, but there is software that reads these two things and comes back with a true or a false, and might even have some detail as to what went wrong with this particular schema. Here's some more that you can do with a schema. We can do things like, have a complex type, we have a sequence. Here we have a string, full name, and a string child name. But we have this min occurs and max occurs. So min occurs is the minimum number of times it can occur, and maximum is the maximum. So min occurs equals 1, max occurs equals 1 means it's required. And so this is required, and we don't have two of them. Two of them would be an error. One of them is fine, so that's good. Here the child name is min occurs 0, max occurs 10. So we have 4 here, and so that's good too. And so that is another kind of XML schema constraint that you can have. Here's a few other data types that we can do. We've done the string, we've done the date. The date looks like this. Dates are 4-digit year, 2-digit month, 2-digit day with dashes. Now there's lots of different ways to represent dates, but the nice thing about this, and you have to put the zeros in, so 09 for September. It means that these are sortable as strings, so that if you do all your dates this way, they're sortable as strings. So you could argue what is prettier, but for computers we don't worry about that. We're arguing about what's the most functional. And then the date time is that same date format with zeros, followed by the letter T, and then followed by hours, minutes, seconds, 0 filled, right? So 9 o'clock is 09, and then the time zone, which we'll talk about a second in the next slide. You can have decimal numbers, and you can have integer numbers as well. And so we are able to sort of render an opinion as to what is good and what is bad in the resulting XML. So dates are kind of interesting. There's, again, we have lots of different formats of dates, 9, 10, 9/10/2002, right? That's a format of a date, but that's one. There's another format of the date, which is 12 December 2000, whatever. And so this is how people show dates. Computers don't want to have all those different dates and don't want to figure those out. They have libraries that produce dates and make them look pretty and for particular locales, but computers really want dates that work best for them. So we just say, okay, we're going to have this year, month, day, time, and then zero fill, hours, minutes, seconds, HMS, and then time zone. Now, computers even prefer a time zone. I don't know if you've used something like your Google Calendar and you take a flight or take a train trip and you end up in a different time zone, everything switches. And that's because Google Calendar is not really storing the time zone that not storing the dates relative in your current time zone. It's storing them in what we call universal time, or Greenwich Mean Time. Zulu time is another word for that. And Z means this time that is the time in London, England, Greenwich Mean Time. And so the thing is that means if this data moves between time zones or crosses the international date line or standard daylight savings time or anything like that, none of that changes. And so we have this internal date and time that's very common in situations where computers are exchanging data that then gets shown with a time zone, converted to the time zone or the local format. That's the right way to do that. And there's a standard for how dates and times are supposed to look. So here's another little example of some stuff. Let's see what we got. Now, if you see this little question mark XML, that's not a problem. That just is a way of sort of putting a header on the whole document that says it's an XML document, telling it that's a UTF-8 document. And that's not really a tag. That's sort of like a marker on the file, so that you can put that there, but it doesn't harm the XML. The outer tag is this tag right here, XS::schema. And then what else we got? We got an address. We've got a string. We've seen all those. Here we have country, and we're going to have a restriction that basically says this is a simple string, but we're going to make it so that you have to list one of these four as the country code. And so here we are down here, and that's UK, and that's UK, and so that is valid XML. Another couple of examples here. Let's see, string. Max occurs unbounded. That means infinite number. There's no limit on the number. You can do that. Min occurs of 0. Excess positive integer. We've seen integer, but you can also say it's got to be a positive integer. Decimal, we've seen that. And then use equals required is just another statement that you can make. I'm not trying to get you to the point where you can do XML schema. Just get you a sense of the kinds of statements that we can speak about when we're talking about what is and is not legitimate XML. So let's talk a little bit about how we might talk XML inside Python. And so, like most things that are in this extended part of Python, we have to import something. And so this is the name of a library, XML eTree element tree. And then as ET, this ends up being a shortcut. So we don't have to type these long things. And so ET is the same as typing that. It's almost like a macro. Now, normally this XML is going to come somewhere from the network, but I'm just going to put this in a string. I'm using a triple quoted string, and so that means that this triple quoted string starts here and ends here, and all these new lines that are here are actually part of the string. So this is kind of like I opened a file and read the whole thing in. But just to keep this totally self-contained, I'm putting it in a string. So the XML would come from some server on the other side of the network. We would get this XML. So that's how it would normally work, okay? So this is the XML right there, and we parse a string of data, and we call ET from string. So we're passing in the less thans, the new lines, the greater thans, all of this stuff we're passing in. And this could have syntax errors in it. So this might blow up if this had a syntax error, like we forgot the little slash or something, there was a syntax error. But this doesn't have a syntax error. So then what we do is we get back an object. I just happen to call it tree because it kind of is like that tree version of the XML. That is an object that we can then query to pull data out of it. So we say tree.find and look for a tag name name. So that finds the tag name is this. It's everything. It's the tag and the text. If we want the text, we add .text, and then that .text, that actually refines it to only the word Chuck. And similarly, if we do tree.findEmail, that tree.findEmail, that finds the email tag, which is this tag. It has a child attribute, and you can get any of the attributes. You say .get. There's only one text child, but there are many attribute children, and so you have to tell it which one you want. And so this bit right here, all of that will resolve down to that string yes. That's what you're going to get there, yes. And so you kind of build up these little finds and call methods. This is not clearly a full introduction to element tree, but you get the idea that you sort of dive down in with these methods that call methods to get little pieces out and parse all of that. Here is a different example. In this one, again, we're using triple quoted string. We always have a single tag on the outside, and then I have a complex type of users, and in it there are two user objects. So this is kind of like a list, right? So this is more than one of these things. So this user can occur more than one time. And again, we take this, we pass that into from string and get back an object that represents the name stuff. Does not necessarily have to be the same as this outer tag. Just a variable. This could just as be easily as X if I wanted. And so now what I'm going to say is, hey stuff, I want to find the tag, the path, users/user. I want to find all tags that match users/user. So that's going to give me a list of two tags, one tag, two tags in a list. Tag. Oops. So two tags. Now I can print out how many I get. That'll be 2 in this case because I got 2 tags. And then I can actually iterate through the list. All right, so I can iterate through the list. So this item is going to iterate first to this tag, and that tag, now it's like in the previous example, we can look for the name tag within there and pull the text out. So we pull that text out, find the name tag, and then within that find the text. And we can find the ID tag and pull the text of that out. So that pulls out this 001, and I've scribbled too much. And then we can item, which is, this is item, is that whole tag, .get X. So that gets the attribute, that gets the 2. That 2 comes down here. Okay? And then item goes to the next one, because item is looping through, so item iterates down to that one and pulls out the name.text, the ID.text, and the attribute.x, and pulls all those pieces out. So this is the basic pattern. You saw one where you're tearing into a single thing, and here you're tearing into something that is expected to occur more than one time. And so that's a quick summary of how you talk to XML in Python. Up next, we're going to talk about the other serialization format, JavaScript Object Notation.